Hello, good day viewers. In this tutorial, I'm going to present to us a sordic equation that involves sort. So in this equation, they're actually asking us to find the value of n that will satisfy this equation. So at this point, you are going to solve for n. Please, if today is your first time of viewing, kindly consider subscribing to my YouTube channel, Esomna of Goodwill Online Maths, and following me on Facebook, Esomna of Goodwill Maths Class, so that you'll be notified once I post a new video. So let's solve together. If you have this, I have 3 root 2 raised to the power of n is equals to 3 raised to the power of 9 times 2 raised to the power of 5 divided by 6. And we are told to find the value of n. You can see this. Remember in laws of indices that whenever we have x, y, all of them raised to the power of n, that is equals to x raised to the power of n, y raised to the power of n, as I've done in my previous video. So applying this law in this equation for this side, you can see that I have 3 raised to the power of n, that's bringing in the powers, times root 2 raised to the power of n, and it's equals to 3 raised to the power of 9 times 2 raised to the power of 5 divided by, for this 6, you can see that I can easily replace 6 to be 3 times 2, because 3 times 2 is actually equal to 6. So if you look here, I can say that 3 raised to the power of n. You can know that a square root is just raising number to the power of half. If we have root 2, it is also equal to 2 raised to the power of half. So I can replace this my root 2 with 2 raised to the power of half. So I can say 3 times 2 raised to the power of half raised to the power of n. And it is equal to 3 raised to the power of 9 divided by 3 raised to the power of 3. Normal 3 is just 3 raised to the power of 1 times 2 raised to the power of 5 divided by 2 raised to the power of 1. So if you observe this well now, you can see that I have 3 raised to the power of n times n times half. You can see 2 raised to the power of n over 2. And it is equals to, observing the laws of indices, when we have 3 raised division law, when we have 3 raised to the power of 9 divided by 3 raised to the power of 1. Since they have of equal base 3 and 3, we can say that we just subtract their what? Powers. So I can have 9 minus, this is 1, times, this have the same base as 2. So I can say times 2 raised to the power of 5 minus 1. If you observe this now, I have an equation like this: 3 raised to the power of n times 2 raised to the power of n over 2 is equal to 9 minus 1 is 8. So I can say 3 raised to the power of 8 times 2 raised to the power of 4. So I have that 3 raised to the power of 8 times 2 raised to the power of 4. If you observe this, from this 3 raised to the power of n, you can see that from this 3 raised to the power of n, that by implication that at this point, you can see that 3 raised to the power of n is equal to 3 raised to the power of 8. Then 2 raised to the power of n over 2 is equal to 2 raised to the power of 4. Therefore, at this point, you can see that n over 2 is equal to 4. If we cross and multiply, you can see that our n is equals to 8. So you can see that 8 is the value of n that can satisfy this equation, because for this power of 3, our n is equals to 8, and for power of 2, our n is equals, for power of 2, our n is equals to 8. So the value of n that can satisfy this equation is that n must be equal to 8.